All right, thanks, Scott, and thanks everybody for hanging on. We're just about done. My name's Abby Field, and I will be going over the initial soil survey of Olympic National Park. And this is the ground survey, not the canopy survey, although that was very interesting, and I want to chat more. So next slide. I am a part of the USDA Natural Resources Conservation Service. Our primary goal as an agency, we primarily work with private landowners on their conservation practices. We provide both financial and technical assistance. But I am a part of the Soil and Plant Science Division, which is a subpart of our agency, and we are in charge of inventory assessment, so looking at the soils and ecology of the US. And basically, this project is a continuation of what we have always done as an agency. This is just specific to Olympic National Park. So we are working on a 5-year interagency agreement with the Park Service, which means we can provide more resources and just more time into this project. Funding began in 2020 with project completion and publication scheduled for later this year. So we're in the final stretch of this project. And so what we will be done with is providing the park with the soil survey, which includes both spatial and tabular data, along with ecological site descriptions developed and associated with each soil component. Next slide. So soil survey products have two components, spatial and tabular. The spatial is the physical lines that you see on the map. So a map unit is an area that is defined and named the same in terms of its soil components. So down at the bottom of this screen, you can see a bunch of different map units. Those are what is labeled with the 4-digit code. Each one of these map units has roughly 4 to 5 different soil components, which is a specific soil with definable characteristics. And the characteristics that we pay big attention to is those that will define its usability. So things like depth and drainage and rock fragment contents. And each map unit has a description that provides details about the different soil components and their likely locations. So with each map unit having 4 to 5 different soils, it is important to know where those soils occur, if it's on like a depression or more of a hill slope position within that map unit. And then our tabular data is kind of the background that goes into the spatial data. We manage this in the National Soil Information System, or NASIS, but what is important for you is Web Soil Survey. So NASIS talks to Web Soil Survey, and that is what is public facing, and that displays all of our data. And this data in Web Soil Survey can generate reports and interpretations. Next slide. So how do we develop and delineate map units? Map unit concepts are developed and delineated based on like combinations of environmental covariates. So this is what can tell us what soils we are likely to see in the landscape. And to do this in the office, we use spatial data and its derivatives. So LiDAR, which is the bottom right hand of the screen, really clues us into the different landforms that we can see. Contour and slope maps tell us how steep that slope is. And of course, ortho aerial imagery is great to use to see kind of what the vegetation looks like on the ground. The Park Service also provided us with landform and vegetation raster maps and climate zone models. So anything we can really get our hands on to describe what the environment looks like, we'll try to use. And then we heavily rely on field observations for ground truthing what we did in the office. And a field observation includes digging a soil pit, looking at what we find in the soil, and then taking a full vegetation site description. Next slide. So soil forming factors in Olympic National Park. As many of you know, Olympic is one of the most variable places in the world. Over the 30-mile transect of the interior unit, so not the coastal unit, we have 9 different soil and temperature regimes. with precipitation ranges from 50 centimeters to 4.5 meters. So a wide variability, especially if you consider the rain shadow of the eastern side of the Olympics. Our elevation ranges from 0 to 2450 meters. And then our landscape and landform variation, if you think about like a broad river valley or a glaciated peak, the difference between those two. And then obviously our ecosystems that go along with that, our old growth rainforests, and then our alpine meadows. Next slide. So why we can use all of these resources to determine what our soil should look like is because soils form under 5 general factors. The biggest one being climate, and then the intense weathering that these soils go through to become what they are. Parent material, if you think about how that soil was deposited and then manipulated into what it is now. And that kind of goes along with topography. If you think about like a river valley, how soil is constantly being deposited with flood events, or like a ridge valley wall, where it is a location of shedding of soil. And then time. Soils need lots and lots of time to develop into very distinct horizons. And when we talk about organisms, both micro and macro organisms, and a big one to consider is plant material and adding organic matter into the top of the soil. Next slide. So soil landscape relationships, that's kind of where it all comes together. So starting on the left, that's our isomesogeutic floodplain forest. That just means that that's one of our lowest elevation sites that occur in river valleys. The parent material alluvium just means that it's deposited by water. And if you look at the picture of the soil, there's not a ton going on besides the stratification of a couple different flood events. But it hasn't had a ton of time to develop. And then the material is just tells you how it was deposited. And then looking at that vegetation, the red alder is obviously not super well established, and you can tell that it's just very frequently flooded. And then comparing that to our frigid Utic moist forest on the right, this site is much more stable and has had much more time to develop. So it is much higher in elevation, a lot colder. And you can see just looking at the soil that it has more distinct layers, which clue us into how it was developed and under what conditions. And then our vegetation as well is much more established. You can see a lot more of those conifers coming in. I think that's it. Next slide. Then ecological site descriptions are associated with each soil that we describe, and they define the ecological processes and disturbance dynamics of an ecological site on a spatial and temporal scale. So if you think about disturbance in these areas, they're not so much human impacted as they are environmentally. So big flood events or fires or wind throw, things like that, they kind of give you a roadmap into what the vegetation should look like post these disturbances. And these sites, like soil, occur over recurring landform, geological, and climate characteristics. They have distinct vegetation that responds similarly to management or natural disturbances. Next slide. So Olympic by the numbers, kind of where we're at the moment. We've had 4 productive field seasons with 37 trips in total. It has been an amazing project to be a part of. We've documented about 850 full sites, including a full soil pit and then vegetation document. We've had 450 note and photo points, and then of course just lots and lots of mental points as we're traversing these areas. Our legend, which is just the collection of everything that we've come up with, consists of 54 soil components and ecological site concepts. And right now we are done with the spatial data. So all of the lines have been drawn, but we are working on that background data that feeds into the map. Next slide. So I just wanted to end with a plug for Web Soil Survey. This is what all of this data will be published through, and it is insane how much data that you can pull from this. So Olympic is one of the last few chunks of land that have yet to be published. Mount Rainier and North Cascades have already been published, so you can go and look to see what you can find there. Keep in mind that this data is a very good baseline, but it is recommended to have site-specific soil investigations if you're doing anything like engineering related. But there's just tons of information here, and I highly recommend you check it out for the public lands that you're working on and even your private lands that you're interested in. Next slide. So this is my contact information. If you have any questions, Max Ross is our project leader, and there has been so many other people that have played a part in this project in many ways. And of course, the National Park Service has been great in providing us assistance in the field and in the office. And then one more slide. If you're curious about the Soil and Plant Science Division of NRCS, or just NRCS in general, go ahead and visit us online, or just reach out to me and I can get you in contact. Yeah, any questions?
All right, thank you, Karina, or excuse me, Abigail. Sorry, Karina was the last speaker. Looks like Kim Bray had a question and it was answered by you already. So any other questions in the group at all? Okay, I do recognize that soil science data is absurd in its extent and its depth. It's amazing how much data you can see in some of those surveys. So it's really cool work. Awesome that's coming along. And we got the Mount Rainier one not too many years ago, and it's definitely use it. So
Awesome.
One of my Taylor just pointed out that I did it on there. I did not mean to, so it's depth. Yeah. Anyway, okay. Any other questions in the group at all? Okay, we got Abigail's contact info if you need it. And if there are any, you can feel free to leave them in the chat as we move forward.